Hello and welcome. Generative AI is a promising technology. It has the potential to transform our lives. It can prove to be a boon and bane at the same time. Boon for those who learn this technology and apply it for their businesses and for individual purposes, and bane for those who stay behind and don't learn this technology. So, with that in mind, I thought of starting this video series on the fundamentals of generative AI focused on Microsoft Azure right now and later expanding into different cloud providers like AWS and GCP. All right, so without further ado, let's get started and dive right into the presentation and learn about this promising technology. See you on the other side. Hello, welcome back and let's dive into the presentation. All right, so what is the objectives of this video? So by the end of this video, you'll be able to define what is artificial intelligence, what is generative AI, LLMs, Azure Open AI and CoPilot, and then you'll also know about transformer model, tokenization, embeddings, and then towards the end, we'll look at the exercise on Microsoft Copilot. All right, so let's get started. So what is artificial intelligence? Let's address the elephant in the room. Artificial intelligence is the capability of a computer system to mimic human-like cognitive functions such as learning and problem solving. So AI systems excel at two things. They learn and solve a problem, just like we as human learn things and solve problems. That's the main agenda and the intention behind designing an artificial systems is that so that they can learn things and solve problem for us. Right, so how does it work? How does AI work behind the scene? Is there some sort of magic happening? No. So AI works by leveraging mathematical principles, as simple as that, and algorithms behind the scenes. So mathematical principles such as calculus, probability, and things like that. So those are the mathematical techniques that are used behind the scenes to design an AI system. So what are the examples of AI? One popular use case of AI, and I'm sure we all might have come across, is the recommendations that are offered on the e-commerce site. So you might have noticed this, that when you are interested in certain product and when you do a couple of searches on Google or other search engine, and then you go to Amazon and try to look for it, that particular product is displayed. Or for that matter, if you go on some other site and see, then within the ads you would see that particular product. So how is this happening? So it's the AI that tracks your history, the browsing history, and then based on that it displays you that product. So, and the other one is self-driving cars, and then bots and digital assistants are also one of the use cases of AI. Okay, so what is Gen AI then? Where does Gen AI fit in? How is Gen AI different from AI? So Gen AI is a type of AI that makes stuff on its own. So you might have, if you might have used ChatGPT or Bard, you would know that those system takes your natural language input and creates or generates text, images or code. So it takes in natural language input and return appropriate responses in a variety of format such as natural language, images or code. So that's Gen AI. And then let's look at the examples as to how it works when you type in natural language. So here is the prompt that I've given to ChatGPT, a popular generative AI platform. Give me a 1-day meal for a keto diet. So here is the day plan that I've got. It has given me a complete meal plan for a day, based on the ketogenic diet. Okay, and similarly, here is the image generation prompt that I gave. Create an image of a flying dog, and here is the image. So we'll also look at this when we get to the lab towards the end of this video, then we'll see in action. And then same as code generation. So I gave the prompt, show me how to code a game for tic-tac-toe with Python, and it generated a code for me. So before the development of or emergence of Gen AI, one used to know the programming to write a code for this sort of game. But with Gen AI, it just give you a natural language input, and it creates a code in the language of your choice. Here is Python. You can generate it in Java or any other language. All right. So let's see how generative AI has emerged. What's the evolution of Gen AI? So here is the slide, uh, and this one, let me minimize this. All right, so let's address this in two format. So this left, towards the left of the slide, talks about where does Gen AI fit into the entire hierarchical category of artificial intelligence. So you've got AI at the top, the broader umbrella within which is machine learning, and then within which is deep learning, and then generative AI is a subset of deep learning. So this is the hierarchical flow you can think of how and where does AI Gen AI fit into the entire AI stack. Now if towards the right addresses the timeline of events that has happened, and that has led to the development and emergence of Gen AI. So 1956 was the year when AI was developed, and then it says what AI, the field of computer science that seeks to create intelligent machines that can replicate or exceed human intelligence. And then within Gen AI, or within, sorry, AI was machine learning. It's again, whenever we hear the word machine learning, we need to understand that's a machine that learns, and it learns based on the data that we provide to it. The sort of data that we provide, it learns on that data. So it's a subset of AI that enables machines to learn from existing data and improve upon that data to make decisions or predictions. And then is deep learning, that was developed in the year 2017, a machine learning technique in which layers of neural networks are used to process data and make decisions. And then generative AI, the landmark year 2021, that gave birth to this amazing and powerful technology, generative AI, that can create new written, visual, and auditory content given prompts or existing data. So this is the evolution of Gen AI. And then, so let's see what are LLMs. All right, so you might have heard of this term, large language model, or LLMs, during your Gen AI read up or videos that you might already watch, or during the conversations that you might have had with your friends or colleagues. So what is LLM? So LLM, also known as large language model, this is a specialized type of machine learning model that we can use to perform natural language process tasks such as determining sentiment, or otherwise classifying natural language text, summarizing text, comparing multiple text sources for semantic similarity, generating new natural language. So yeah, these are the tasks that a LLM can handle, that's designed to perform NLP tasks, natural language process task. So it can summarize a task. You give it a bulk of text and ask it to summarize, it would do it for you. It can generate a new language, a natural language output that we have already seen, and it can also compare multiple text sources for semantic similarity. All right, so now one thing to note here is this, that mathematical, as I said, mathematical principle behind the LLMs can be complex. All right, it has got complex probability and calculus and things like that happening, and that's out of the scope of this video and also the AI-900 exam. However, we look at the basic architecture of the model, basic architecture of that's used across different LLMs, be it Bard or ChatGPT. All right, so let's see on the other slide. So transformer architecture or transformer model. So large language models are based on transformer architecture. Okay, and that architecture has got two components or two blocks, you can say. One is the encoder block that creates semantic representation of the training vocabulary. Okay, so you feed in the text that you were while training, and then while training, when you give huge amount of text to your LLM, that creates that semantic representation. Okay, when I said semantic representation, what I mean is it creates that linguistic representation, and then there is a decoder block that generates new language sequences. Okay, now this specific implementation of the architecture might vary. Okay, what I mean by that is, let's say BIRD, which stands for bidirectional encoder representations from transformers or BERT, which was developed by Google, they use only the encoder block. Okay, within this architecture, they only leverage the encoder block, whereas ChatGPT, which is based on generative pre-trained transformer developed by OpenAI, only uses the decoder block. So the way each company implements this model or architecture is different, but this is what they use behind the scenes. Okay, now let's look at what is tokenization. Okay, so tokenization is uh, when you first train a model, the first step in training a transformer model is to decompose the text or training text into tokens. So when you feed huge amount of data to your LLM while training, what happens is that text is decomposed, broken down into tokens. Okay, when I say token, I mean the numbers. Okay, for example, let's look at the example. Consider the following sequence. I heard a dog bark loudly at a cat. Okay, when you feed this particular sentence to your LLM, what it does is it breaks it down into a token, and this is what happens. I is assigned number 1, heard is 2, A is 3, dog is 4, so on and so forth till cat, which gets number 8. All right, this is what tokenization is. Now, one thing to note over here is, for the sake of simplicity, I've mentioned that this is how it happens, but it's not necessary that every distinct word is assigned a new token. It is very much possible that partial word might get it one token, or a combination of different words and punctuations might get a token. But tokenization does happen behind the scenes. Words and letters do get converted into tokens, and they are in the form of numbers. All right, now this sentence now can be represented with token like 1 2 3 4 5 6 7 3 8. Okay, 1 2 3 4 5 6 7. Since A has already got 3 over here, that's the reason it's not getting a new token, but still being represented with 3, and then cat gets 8. Okay, that's how it happens. This entire sentence gets this letter. Now similarly, the sentence I heard a cat could be represented as 1 2 3 8. Right, perfect. Hope you've got what tokenization means. Let me proceed ahead. Now let's see embeddings. Now if you look at this previous screen, these tokens, once they are converted from text to tokens, they don't really make any sense. Okay, they don't really make any sense. So in order to get a sense out of that token, what LLMs do is they represent that token into a vectorial or a contextual format. Okay, so in a vector space, those tokens are represented, and so here is on the screen you see a three-dimensional vector space, which you can see that skateboard, the word skateboard is represented here, which has got 10 as their token, and this is their vector representation. And that word similarly, dog, cat, bark, and meow, they've all got this is their token, and this is their vector representation. Now, one thing to note here is, why are we doing this? I mean, what is the benefit of doing this? So when to get a sense of this, LLMs present them into a vector space. Okay, and also another thing to note is, the more closer each word is to the other in a vector space, it means that they are more semantically related. Okay, dog and cat related. Okay, bark and meow, they are related. That's the reason why they are represented closely in a vector space. Okay, uh, now, all right, so this is also done to create a vocabulary that encapsulates semantic relationship between tokens we define in the contextual vector, and this is also called embeddings. So I hope this embeddings makes sense. I know it's a very complex topic, and difficult to understand, but yeah, I think this explanation has helped. So let's proceed ahead. All right, so now let's get down to the nitty gritty of Azure AI. Okay, so what is Azure Open AI? So Azure Open AI is Microsoft Cloud solution for deploying, customizing, and hosting your large language model. Okay, So you you know OpenAI has developed their large language model called ChatGPT, GPT-4 or GPT-3. That model is available on Microsoft's catalog, and you can deploy it. You can customize it. When I say customize, you can fine tune it, and you can host your own large language model as well. All right. So as I said, this OpenAI brings together the best of OpenAI's cutting edge. Azure OpenAI brings together the best of OpenAI's cutting edge models and APIs with the security and scalability of the cloud. So you can, when you design these or when you deploy these models in an enterprise setting, you need to have security and scalability features as well. That's what Azure offers you. Okay, let's look at what are the models that are available in the Azure's catalog. All right, GPT-4, that's the latest model from OpenAI, a GPT model that can generate natural language and code completion based on natural language prompts, right? And then you've got GPT 3.5, which is a model which is a little bit less in version, that generates natural language and code completion based on natural language prompts. Does same function, but GPT-4 is advanced a bit than GPT 3.5. And then embedding models. So embedding models, as we know, these models, what they do is they convert text into numeric vectors, as we have seen in the previous slide. That's what embeddings do. And there is a separate model that can help you accomplish this task and are useful in language analytics scenarios such as comparing text sources for similarity. Okay, and then you've got DALI E models which generate images based on natural language prompts, and it's in preview right now. Okay, so here is Azure AI Studio's screenshot for you. um, and this Azure AI Studio, this is how it looks like, where you can deploy your model, host your model, and you can access chat playground and completions playground as well. Okay, let's proceed ahead. Now, what are co-pilots? Well, you might have heard of this term co-pilot during while you read a lot of Microsoft documentation or during the Ignite events. So it's a term coined by Microsoft, but it's being used across the industry now. And Copilot is nothing but an AI assistant. Like the way Copilot works in an airplane, like beside a pilot sits co-pilot that helps the pilot in navigating the plane and other things. Similar job is co-pilot is doing, and it's kind of an AI assistant here. Okay, co-pilots are often integrated into other applications and provide a way for users to get help with common tasks from a generative AI model. So you might have developed your own application, and within which you can develop your own co-pilot, and it will help you accomplish common tasks. Okay, that's what the goal and how you can use your co-pilot. Okay, let's see how this entire scenario plays out. Okay, um, right. So let's start right from the scratch. You have trained your LLM. Let's say LLM is trained using the data. You've got huge amount of data. You've trained your LLM. Okay, you've got your own custom LLM. Now you can use Azure OpenAI to make this LLM available. So Azure OpenAI makes this pre-trained model available. Pre-trained model available. Okay, you can host or make your LLM available on Azure OpenAI, and you can deploy this model to make it available for your apps. Okay, and then now you can developers can build Copilot using this LLMs. This is where the Copilot comes into the picture, and then once you have this Copilot pilot developed, business users can use this Copilot to boost productivity. Okay, this is what is happening. All right, hope that was helpful. Let's see what prompt engineering is. So what is prompt? Let's see what prompt is first of all. Prompt is nothing but an instruction you provide an LLM when you want it to do certain task. Okay, so let's say you want LLM to create a diet plan for you. You can say just create a diet plan for me, and then it creates that plan. The prompt that you give, the instruction that you provide, that's called prompt. Okay, and the process of improving that prompt is called prompt engineering. All right, that's what prompt engineering is, nothing else. And then there are certain techniques that you can use to improve your prompt. We will look at that. Okay, let's look at what is system messages. So while you train an LLM, there's something called system message as well. The system message sets the context for the model by describing expectations and constraint. So when you train a model, you set a system message. When you set a system message, what you're essentially saying your model is, this is what you're supposed to do and this is what is out of your scope. Okay, let's look at an example. Okay, let's system message is I've trained an LM, and let's say this is the system message I've given it. You are an AI assistant that helps people to find information and response in rhyme. If the user asks you a question you don't know the answer to, say so. This is the system message that I've set. Now a user comes up and says, and types in this prompt, what can you tell about me, John Doe? Okay, now assistant would respond, since it doesn't know, it says, dear John, I'm sorry to say but I don't have info on you today. I'm just an AI with knowledge in my brain. So since it doesn't know about who John Doe is, it says it so. Okay, it says I don't know. All right, now how to write good prompts. Okay, now submit clear specific prompts to achieve better results. So you have to be clear and you have to be specific when you submit a prompt to achieve a better result. It doesn't need to be an ambiguous one, to achieve the good result. Right, let's see an example. Create a list of 10 things to do in London during August. So let's say you have landed in London in the month of August and you're not sure what you can do there. Then probably you can type in this prompt. Okay, so the unclear prompt or an ambiguous prompt could have been, in this case, is created 10 things to do in London. This would have written 10 things which might have not been relevant for the month of August. So being specific and clear helps a lot here. Okay, now let's providing examples. Okay, before that, let's talk about zero shot, one shot and few shot learnings. Okay, so zero shot learning is when you generate a response from an LLM without giving it any prior example. Okay, that's what zero shot learning, and that's what LLMs are mostly used for. Okay, and then there is one shot learning. So you provide one example of the type of output you require to the LLM, and it gives that sort of output. That's called one shot learning. Okay, and then so you can say, probably you can say, you can give an existing email, and then in the other line you can say draft an email of similar sort addressing a different recipient. That's one shot learning probably. And then few shot learning, you gave more than one example of the output you require. Okay, so now let's look at grounding data. So grounding data is providing more context to the model. So this zero shot, one shot and few shot learning is kind of you're providing examples, whereas grounding data is you provide more context. Okay, example, suppose you want to use an LM to generate a summary of an email. You can include the email text in the prompt with instruction to summarize it. You see, so LLM, so the email here acts as a grounding data, and based on that data it generates you the summary of it. That's called grounding data. This provides benefits of fine tuning without having to train a custom model. Okay, so grounding technique, you can use this technique to get the benefit of fine tuning without having to train a custom model. Okay, all right, let's look at the exercise. Okay, let's look at the exercise. There you go. So let me bring this down. Okay, so in this exercise we're going to use Microsoft Copilot, and here is the Microsoft Copilot that I've already launched. And okay, so you go to um, copilot.microsoft.com, and then as part of this exercise we're going to look at three things. We use prompts to generate responses, we'll try to generate an image and try to generate a code. Okay, so let's type in this prompt. So this is the prompt. What are the three pros and cons of traveling in the winter? You go here, you come, you type in this, enter, and here is the response it's generating for you. It says, Okay, while it does generate that response, so yeah, hello, this is Bing. I can help you with your question. Uh, okay, there you go. It's generating a response for you. Okay, now similarly, so it is traveling in the winter can have both advantages and disadvantages depending on your preference, budget, and destination. Here are possible pros and cons of traveling in the winter. Okay, and then now you can say a follow up. Find me three more pros. Enter. It's generating a response for you. Okay, there you go. Sure, I can. Right. So this is how it works. It is a CoPilot, an offering from Microsoft that's using behind the scenes power of Bing and generative AI models like ChatGPT 4, and CoPilot is uh, you know is abstracted from that. So now let's try to generate an image. Create an image of an elephant eating a hamburger. Create an image of an elephant eating a hamburger. Let's see. So now it's going to use DALI E model behind the scenes to generate this image for us. Mm, you know, there you go. Oh, yes. Your image is generating, so it's generating an image, and there you go. Elephant eating a hamburger. All right, perfect. And then let's look at something else. Now let's try generating a code. Use Python to create a list. Let's type use Python to create a list. Let's type in this over here. Uh, List is a collection of items that can. Okay, there you go. It's has given you what a list is, and then also created the code for Python. All right, so this is Gen AI and Copilot in action for you. All right, so yeah, that was the lab on or the exercise on Microsoft Copilot. So recap, let's do a recap. So what we have learned, we have got to know about artificial intelligence, Gen AI. We also know what LLMs, Azure Open AI, and Copilot are. We know how transformer model works, and then tokenization and embeddings. And then at the end, we have looked at the exercise on Microsoft Copilot. Right, hope this was helpful. Thank you so much for being here till the end, and hope this was helpful. See you on the other video with more fundamentals of generative AI and Azure Open AI. All right, thank you so much. Wish you a good day ahead. Take